Hi everyone and welcome back to the channel. Today I'd like to go through 13 TI-36X Pro calculator tips that will help you save time on your FE exam. You have around 3 minutes per question on the FE exam, so these calculator tips could take a 3-minute question and turn it into a 30-second question, right? Saving you time on the exam and giving you time for those more difficult problems. You can see that what we're going to do in this video is we have 5 different problems, and each of the problems bring out some calculator tips that I'm going to show you how to use on this kind of digital calculator over here. Additionally, there's timestamps in the description below, so you can go to your tip of interest, or you can watch the whole video. All right, I know this says 30X Pro, but it's the same thing as a TI-36X Pro. Let's get right into the video. All right, so first thing is we have this problem here. It says, what is the area enclosed between the two functions shown below? You can see there's a kind of a line and a parabola, and there's an intersection here. And I kind of marked off these intersection points with red dots. The first thing you should be thinking of in a problem like this is that there's an area mentioned, so probably we're going to have to use some kind of integration. I'm thinking we're going to integrate that upper function, subtract it from the integral of that lower function. So what that's going to give you is this kind of hashed area here. But we need to know first the intersection points. And in order to find these red intersection points, the ones that I marked off with these dots here, what we're going to do is we're going to go ahead and set these two functions equal to each other. So I'm going to set negative x plus 4, that's the line, equal to x squared minus 3x plus 2.5. If I go ahead and move that x over, what I'm going to get is x squared minus 2x, and move the 4 over, I'll get a negative 1.5. That value is equal to 0. So the first thing we see here is that we have a polynomial, and you can see in the upper right-hand corner here, I have that the first tip in this problem is going to be finding the roots of a polynomial. Okay, so how we're going to do that is we're going to click second, poly solve. And you can see the upper form of the equation is what we have. We're solving a quadratic. We're going to click enter here. We're going to input the coefficients on the kind of standard quadratic that we have, which is ax squared plus bx plus c equal to 0. So from here, we can read off by inspection that a is equal to 1, b is equal to negative 2, and c is equal to negative 1.5. We're going to go ahead and solve that. And we did our first calculator tip here. We got the roots x1 corresponding to the lower bound and x2 corresponding to the upper bound. That kind of makes sense because we have one that's negative and one that's positive. Okay, now we're going to get into our second calculator tip here, which is variable storage. Now, you can see how many decimal places this thing has in terms of the roots, right? There's opportunities to make rounding errors, and it's just a waste of time to be writing down these numbers when you could just store it inside of your calculator. So in order to store the output from polynomial roots into a variable, what we could do is store that lower root, which is x1. We could store that in a variable called z, and I usually store them in the later variables because x and y are used sometimes to get some solutions. I recommend storing them in these later variables. X1 I have stored as z. X2, the upper bound, I have stored as t. Click enter here. Okay, now we successfully have them stored. We can click second and quit. And in order to view what kind of variables you have stored, you can click second, recall right here. And you can see that we have z as the lower bound and t as the upper bound. Let's go ahead and write down. Let's go ahead and write that down, right? We have z as this lower bound. I usually mark it off with a box to kind of denote what I have is a variable stored in my calculator, and t is the upper bound. So now that we have the bounds of integration z and t, and they're stored in our calculator, we're going to go ahead and perform our integration. Okay, So you can see that if we found the area under this line, what we'd have is kind of this trapezoid here. If we then subtracted off the area associated with the parabola, which is the integration under that parabola between the bounds, then we'd be left with just this hashed area. So what we're going to do mathematically is we're going to go ahead and find the integral from our lower bound z to our upper bound t. And once we go ahead and find that integral, we're going to take the difference between negative x plus 4, that's that kind of trapezoid area, and subtract off the integral of that function, that upper, or I guess the polynomial, the quadratic, right? X squared minus 3x plus 2.5. And the result of this will be that hashed area. So this is what we're looking for. And we're going to get into our third tip now, which is numerical integration. Okay, so how are we going to perform numerical integration? We're going to look for that integration sign, which is right here. Second, click on that integral stuff. And we're going to plug in first our lower bound here. Our lower bound, we can just say is that variable that we had, z. And you can access your variables by clicking this button over and over until you get to the variable that you want. So I clicked it, I guess, 3 times for z. I'm going to click this up arrow here. Make sure that I'm on my upper bound. Go ahead and access t, clicking it 4 times. All right, so now I have a similar form to what I have here. I'm going to move into the expression. All right, so I'm in the expression here. I'm going to first type 2 parentheses just to make sure that I'm consistent. All right, so we have negative x. So this is kind of where that why I stored it in later variables, because if you put x here, the calculator is going to get confused and you'll be referencing a number here instead of a variable, right? Negative x plus 4. All right, so we have that. We're going to go ahead and close that parentheses. Subtract off x squared minus 3x plus 2.5. We're going to close that parentheses here. And looks like we are good. Let's click enter here. Okay, so we got our final answer here. Final answer is going to be 5.27 is the solution. And we really didn't have to write down much, right? That variable storage is super powerful. And if you can get comfortable with it, it could save you a lot of time writing down unnecessary information. So we got 5.27 for the upper one. We went through these 3 tips here. Clear our calculator and move on to the next problem. Okay, so this problem, we have a matrix A that's shown below, and our goal is to find, for the first part, A inverse, for the second part, A multiplied by A, and for the third part, the determinant of A. So let's go ahead and first answer the first part, matrix inverse. Okay, so how you put matrices inside of your calculator is you basically click on second, click on matrix there, and you have options here for 3 matrices, A, B, and C. You can edit the definition of those matrices here, going over to the edit option, clicking on enter, and we have a 3 by 3 matrix, 3 rows, 3 columns. Let's enter that for 3 and do the same thing for the columns. Okay, so now we just type in our definition, right? 3, 2, negative 1, 1, 1, 1, and then 2, negative 1, and 1. Okay, this seems to be right. 3, 2, negative 1, 1, 1, 1, and 2, negative 1, 1. So that looks right. We're going to click second, quit, and we're going to go ahead and find that inverse. We're going to load in our matrix here, matrix A, and we're going to click second, matrix, move over to the right where you can access these different functions that you could perform on matrices. We're going to go down to inverse. That's option 3. We're going to click enter here 2 times. And we have what the matrix inverse is. And this is A inverse. That's the solution to the first part. What about for the second part? We need to find A multiplied by A. So you can quit out of this. And what you're going to go to is, again, to access that matrix, we click second matrix here. We just do matrix A multiplying second matrix A. And we get the product of those two matrices. So that's the answer to option to question 2. Now, what about for that third question? We're going to go ahead and find the determinant of this matrix A. So what you're going to do is click second matrix, go over to the math option and click on determinant. And you're going to feed in that matrix A, second matrix, click on matrix A, close up that parentheses, and we're going to find the determinant, which is 11. Okay, so we found all those options. We addressed all these tips in the upper right. So we're at tip 7 at this point. Let's move on. Okay, so we're given vectors A and B shown below, and we're asked to find the scalar projection of A onto the direction of B, as well as the cross product of A and B. Okay, let's first talk about how to solve the problem. When you're looking for the scalar projection of one vector onto another, if you have a vector A like this, and let's say you have a vector B like this, if you find A dotted with B, that's equal to A, B, cosine theta. We kind of rearrange the terms to make it a little bit simpler to see. What we have is A cosine theta, if this is the angle theta between the two things. A cosine theta represents the projection of A onto B. And then we go ahead and scale up that projection by an amount equal to B. So in order to find the scalar projection of A onto the direction of B, just that A cosine term, what we're going to do is we need to get rid of the magnitude of B. So we're going to do this operation, A dotted with B divided by the length of vector B. And that's going to give us our scalar projection that we're looking for. That is going to be our solution. Right, the result of this will just be A cosine theta. So we're essentially dotting A with a unit vector pointing in the direction of B. All right, let's go ahead and first we're going to find the vector norm or magnitude, and we're going to do that for vector B. And we're going to go ahead and store it. Then we'll take the dot product of A and B after we define those vectors, plug it into this expression, and we'll find our answer. Okay, so how do you define a vector? We're going to click second, vector. All these operations are pretty similar, right? We're going to go over to edit, and we're going to define a vector u. That vector u is going to represent our vector A. So that's going to be a 3-dimensional vector. It's 3, 4, -2. All right, so we have our vector A defined. Let's go ahead and note down that that is our vector u. A is our vector u, and B is going to be our vector v. Second vector, we're going to go ahead and edit the definition of vector v to match our definition of vector b. Okay. Vector b is 2, 0, and the last thing is 1. Okay, so we have the definition stored in B, stored in V. Now, what is the dot product of A and B? We click on second vector. Go ahead and click on the dot product here. Now we want to take the dot product of two different vectors, vector u, second vector here, vector u, and we're going to go ahead and place a comma here between them. Second vector, and we need to access our vector v. Close that parentheses up, and we can see that the dot product is 4. Now the dot product is a super quick operation. Maybe you might not even need that for this kind of problem, right? It took us a little bit of time, but it's good to know, right? You can see 3 times 2 is 6, minus 2. We could have did that in a couple of seconds, right? Okay, A dotted with B. We know that the result of that is 4, and we can go ahead and I'll just show you how to find the magnitude of vector B. Second vector, we're going to go ahead and click on the norm or magnitude. That's option 3 here. We're going to go ahead and plug in that vector V. V represents B, and it's the square root of 5, and that makes sense, right? 2 squared plus 1 is 5. The square root of that is the square root of 5. So the result of question number 1, 4 over the square root of 5 is the answer to that question. Now, what about the cross product for A and B? This one is, I think, a little bit more time saving. If I see a dot product or a magnitude, maybe I might not use these calculator tips. What about if I see a cross product though? Probably I will use these calculator tips. Second vector, we go over to the math option here. We're going to click on cross product, option 2. We're going to go ahead and plug in the two vectors that we have. Second vector u. Insert a comma here between the two. And we're going to click on second vector v. Close that parentheses up, and what we get is 4, -7, and -8. And that's super cool that we can get that cross product in such a quick time, right? 4, -7, and -8. Yeah, cross product is annoying operation, so good thing that they have that option. We went ahead and went through those 3 calculator tips there. Let's move on to some of these complex expressions here. So the first tip we're going to go into is operations for complex numbers. You can see that, in general, we have a bunch of different operations here. So we're going to go ahead and do that. And I'm going to show you how to convert it into polar form with this upper option. Let's go ahead and plug into that. Okay, so in order to have a complex number inside of the TI-36X Pro, you're going to click 2 plus 5, and there's an I variable right here. So you go ahead and click that 3 times, and you have your I. And it's as simple as that, right? You want to go ahead and divide off 1 plus 2I multiplied by 4 plus 3I. And that's it. Click on enter here, and we get a complex number in the form of A plus BI. This upper question is asking for it in polar form. So we can go ahead and convert our answer to polar form, clicking on second complex. Once we click on that complex, we're going to go ahead and convert it to polar form. We're going to take our output and convert it to a form r at an angle of theta. Click on enter here. Enter again, and here it is, right? Our solution here is 0.481 at an angle of, looks like negative 32 degrees, negative 32.1 degrees. Okay, so we found the solution to the first question, and that was using operations for complex numbers, as well as converting to polar form. And I'm going to show you as well how to input imaginary numbers in polar form and perform operations with them. So first thing we're going to do is we're going to input 5 at an angle of 30, 5 at an angle, second complex. You can see there's an angle here. You can just click enter there. 5 at an angle of 30 is what we just inputted there. Plus, now I'm scared about the parentheses here. So I'm going to go ahead and insert a parentheses. Second insert. Go ahead and stick this in here. Add to that 3 at an angle of 45. 3 at an angle, second complex. Angle is the first option of 45 degrees. I'm going to close this up and perform this operation. And what we get is this answer here. This is an answer in the form a plus bi, which is exactly what we want. So we're going to go ahead and log this down. If we wanted to convert it to polar form, we could do that as well. So this is 6.45 plus 4.6, 4.62i. Now, is the imaginary number really there? Let's make sure. Yes. Okay. So these are the two solutions, and we went through these 3 upper calculator tips here. We're on calculator tip 13 now, which is our final calculator tip. We're going to do this last question on solving system of equations. Before I do that, just go ahead and reset my calculator real quick. Make sure none of my variables are kind of mixing each other up. And in order to solve a system of equations containing 3 different variables, 3 unknowns, we're going to click on second. We're going to go ahead and click this system solve button right here. Click on 3 by 3 linear system. There's 3 equations, 3 unknowns. And we're going to go ahead and plug it in, right? X has a coefficient of 1 here. Y has a coefficient of 4. Z has a coefficient of -2. And that value is equal to 16. So that's kind of how it goes when you're inputting these values. 2, -1, that's what I'm seeing. 3, and -2. 3, -2. 5, and -5. Now we're going to go ahead and check our input, make sure that we're correct. 1, 4, -2, 16. 2, -1, 3, -2. And then 3, -2, 5, and -5. It looks correct. We're going to go ahead and solve this system. And we get the fact that x is equal to 2. Y is equal to 3. And z is equal to -1. If you're enjoying this video and you're learning something, consider leaving a like and subscribing for more content like this. Additionally, if you're prepping for the FE Mechanical exam and looking for a resource that will help you pass, consider checking out my software, FE Interactive. It's the 3rd link in the description below, and it'll give you access to multiple different sections, practice exams, review and improve sections, as well as a tips and tricks section, which helps you use your calculator better and save time on test day. An analytics page, which ties all of the different pages together. You get data for each of those pages, where you can view, for instance, how you did on each exam, as well as a detailed solution manual for each exam, so you know exactly where you're making the mistakes, what exactly is the misunderstanding coming from. And all of those are tied together with an overall data point. The overall data point can be reorganized in terms of performance so that you know, what are my top 3 subjects? What are my bottom 3 subjects? Having this kind of data is super valuable since it helps you isolate your weaker points and fortify your strong ones. I'm confident that my software, FE Interactive, will help you pass the FE Mechanical exam. And again, you can check it out using the 3rd link in the description below. You get 2 months of access for $9.99. Let's get back into the video. Okay, so that's all our tips that we had to work on today. If you enjoyed the video, consider leaving a like and subscribing for more content like this. Thank you for watching. I'll see you in the next video. Goodbye.